All right, good morning, afternoon, everybody. Welcome to day 5. So today what we're going to do is you have the slides presentation to go through, and then you also have your exit ticket for today to go through. And we're going to go over a little bit more about each here in a sec. So today what we're going to be trying to do is identify current, resistance, and voltage. This is something we call Ohm's law. So we're going to be talking a little bit about that and the relationship between current and voltage, current, resistance, and voltage and resistance. So what's a circuit? A circuit or an electrical circuit is a complete pathway through which electrons can flow or charge. So in this case, negative charge being electrons. So electrons flowing in a circle, that's a circuit. So it has to be a complete pathway though, because otherwise they won't be able to flow. So if you look at the pictures down here at the bottom, this one is not a complete circuit, and you can tell because the light bulb is not lit up, right? How do we know that? Well, right here, right? Our circuit is not complete, where this one is. So that circuit is complete. Now we have a light bulb that can flow. We have a whole electrical pathway. So electrons flow from the negative end because electrons are negative, go through all the way around in a circuit. Oops. Oh, let's get rid of that. Electrical current is the continuous flow of electrons or electrical charge. We measure current in something called amps or amperes. That's how much current is flowing or how many electrons are flowing throughout a circuit. The amount of current leaving a battery must be the same as the amount coming back in. So throughout a whole current, it cannot have more current leaving a battery than coming back in. So it all has to be the same. When we look at the flow of electrons, all right, there's two different ways of looking at traditional and conventional. So they came up with this before they knew what the electron was when they came up with traditional, where it goes from positive to negative. So this one here on the right. So in traditional circuits, we would have the electrons flowing from positive to negative, but we know that's not true anymore. We know that electrons are negative, so they're going to flow from the negative side of the battery around the circuit, right? And the only reason we have that is because that's what we knew, or sorry, we've recently discovered that since we've been working with circuits, right? So there's the traditional one, which has positive to negative, but we really know now that it goes from negative to positive as we flow around a battery. Voltage is a measure of how much potential that energy that the um, circuit can do, right? And it's caused by a difference in electrical charge. So we're going to have a positive side, we're going to have a negative side. Those negatives are going to want to go around the circuit to make sure that they can get to the positive side. So when a battery is dead, right, that means most of the electrons, right, there's not enough of them to push through whatever circuit it is anymore. So you can think of voltage as like the pushing current through the wires. Um, there has to be a difference in voltage from one end of the battery to the other to cause current to flow, and we measure them in volts. You've probably heard that term before. Batteries use chemical energy to do that. Lithium batteries, right, like your cell phone battery, use lithium ions to create that potential difference. Um, and we have the same kind of deal in outlets, but it's a little bit different. So we're going to have a different potential there. The higher the voltage, the greater the current, but the reverse is not always true. So if voltage goes up, no matter what, our current's also going to go up. So as V goes up, that means current, we use I. So V is equal to voltage. I is current. All right. So as V goes up, I also goes up, or current also goes up. But if current goes up, voltage always or doesn't always go up, and we'll explain why that is here in a sec. Resistance is the last piece of this. So voltage equals current times resistance to make Ohm's law, which we're going to get to. So the measure of how well an object conducts electric current. So the higher resistance, the less it wants to let electrons flow through it, the less it wants the electrical charge to flow through it, right? So you can think of resistance, a high resistance, it means it's really, really difficult for electrons to flow, right? If it is a low resistance, then it's really, really easy for electrons to flow, right? We measure them in something called ohms, right? So ohms are the unit for resistance. We also use the symbol, let's try that again. We also use the symbol omega. So that's the Greek letter omega. And we also use that. So you'll see me write on our keys for different things. I'll either write out ohms when I'm talking about resistance, or I'll just put the omega symbol. So again, high resistance means it's really difficult for current to flow. Low resistance means it's really, really easy. All right, so your assignment today is to complete the exit ticket by 2:30. All right, so we should be on day 5 already. And if we go to day 5, right, we have our exit ticket right here. Right? To find the current and voltage and resistance and give the units for each. So there's your exit ticket. We definitely just went over all of that stuff. All right. Looking forward to seeing you again on day 6, on day 6. Give me a call, shoot me an email if you have questions. Join us for the 9 o'clock office hours through Google Meetings. All right. Thanks, guys. Have a great day.